contains some references and links to other videos I've done since then that go much deeper into some of the subjects. So without any further ado, let's answer the question, what is an electric vehicle? Let's look at the different types of powertrains available in vehicles. The overwhelming majority of cars today burn gasoline or diesel. Fuel is the energy source, stored in a tank and burned inside an engine. That's why we call them internal combustion engines or ICE. That's because engineers love acronyms. Since fuel is being burned, there is exhaust, which has caused environmental problems for decades. Smog, acid rain, and now climate change caused by greenhouse gases like CO2. An electric vehicle, which really should be called a battery electric vehicle or BEV, uses electricity stored in a battery that drives an electric motor. It has no tailpipe, but the electricity does have to come from somewhere, so they are not completely guilt-free when it comes to CO2. Hybrid electric vehicles, like the Toyota Prius, use a small battery and a small electric motor to improve the efficiency of the combustion engine. It still burns gas and creates CO2, but it produces less because it is more efficient. The next category of vehicle combines a hybrid and an electric vehicle. It's called a plug-in hybrid electric vehicle. And because engineers love acronyms, it's called a PHEV, sometimes pronounced FEV. Toyota calls this option Prime. Jeep uses the term 4xe. If you plug it in, it can automatically drive somewhere between 15 to 30 miles on electricity alone, and it also has a gas tank for when the battery runs out. The car will automatically switch between electricity and gasoline power as needed. This sounds great, but the convenience of having two energy sources comes with cost and complexity. The key thing to remember, PHEVs are only more efficient if you plug them in regularly. If you don't plug them in, you've wasted your money and you really probably just should have bought a hybrid. I have a whole video dedicated to PHEVs, so how about hitting that subscribe button if you're interested? Lastly, we have a hydrogen fuel cell electric vehicle. It uses hydrogen gas stored in a tank that converts it to electricity using something called a fuel cell. It is literally NASA technology, and the only thing that comes out the tailpipe is water vapor. In California, you can lease a vehicle like the Toyota Mirai and find some hydrogen filling stations. Outside of California, though, hydrogen vehicles are not ready for mass adoption. The big question in the industry about these vehicles is, where does the hydrogen come from? Some sources of hydrogen are clean, called green hydrogen, but they're expensive. The most common source of hydrogen produces CO2 as a byproduct. They're called gray or black hydrogen. And then there are lots of other colors used to describe how hydrogen is produced. I'm not going to cover hydrogen vehicles in this video. Simply put, there are a lot of issues with hydrogen-powered cars. The technology may only make sense in big trucks. Electric vehicles are not new. Early automobiles were powered by either gasoline engine, steam, or electricity. At the time, gasoline filling stations were hard to find, so electric vehicles were a viable option in cities. They were easier to start than hand cranking a gas engine and much quicker to start than boiling water for steam. By the 1920s, as more gasoline stations started to appear, most electric vehicle manufacturers faded away. If you'd like to know more about the history of EVs from 1895 until now, check out this video. So why are we even talking about bringing back electric vehicles? Let's go over 3 key benefits. First, they pollute less. Climate change is real, and EVs are part of the solution. Transportation is the largest contributor of greenhouse gases, and of that, light-duty vehicles are responsible for more than half. You may have heard people questioning the environmental benefits of EVs, and I'm telling you that they're mostly wrong. Even when electricity comes from coal, and you factor in the manufacturing of the battery versus an engine, an electric vehicle produces less CO2 over its lifetime. And as we switch from burning things to make electricity to wind, solar, hydroelectric, and yes, nuclear, the CO2 reduction for an electric vehicle adds up even quicker. I'll put links in the notes to reputable studies that all come to this same conclusion. Second, they have a lower total cost of ownership, especially if you charge them at home. Most electric vehicle owners prefer to charge at home and overnight when electricity is cheapest due to low demand. They also cost less to maintain with no oil changes and less brake wear. Major fleet operators are adding electric trucks for this very reason. They cost more upfront, yes, but less to operate over their lifetime. They're not hippie environmentalists. They're doing this to save money. Electric vehicles are fun to drive, and this may be the very best reason, and also the one that Tesla really got right. They made EVs cool by taking advantage of their ability to instantly make peak torque. They accelerate quickly and have a low center of gravity. Now, not all EVs offer ludicrous acceleration, but even the slower ones have a smooth, effortless power delivery. Now, to be fair, there are concerns with electric vehicles. The one you'll hear about the most is range anxiety. In the 2010s, electric vehicles from manufacturers not named Tesla often had a range of only 100 miles or less. They were called compliance cars because manufacturers rushed them out to earn credits from the government. Today, most electric vehicles in the US have a range of over 250 miles on a full battery. And marketing is selling you on the idea that you need to have 300 miles of range or more. But I want to tell you that it's not range that is causing anxiety, but rather it's charging anxiety. Which leads us to the second major concern: how and where to charge your electric vehicle. We weren't born with the ability to add fuel to a car. We figured it out growing up. Charging an EV is an even different experience. It can be intimidating, and sometimes it doesn't go as planned. Home chargers are relatively simple devices, but not every house has an outlet in the right place. Public charging is what makes the headlines. Tesla built out their own network of superchargers, and they work very well. Other companies have gotten into the business. It's a crowded space with lots of changes and challenges. The industry is sorting this out, but right now it's not as intuitive, nor as widely available, nor as reliable as pumping gas. But like I said earlier, gasoline wasn't always widely available either. We'll figure this out. Lastly, most people just don't like change. It's not in our DNA to accept something different without questioning it. And EVs have gotten sucked into misinformation and politics. To illustrate, let's look at an example of the product adoption curve. It maps out different phases and what to expect anytime a significantly new product or technology gets introduced to the marketplace. You'll see people getting on early, call them innovators, and then other people holding out forever, skeptics. In the US, we are just transitioning into the early adoption phase. This is still very early in the acceptance of electric vehicles back into the marketplace. At this phase, skepticism, confusion, and changes within the industry are all normal. So don't worry if you're feeling a little overwhelmed by all this stuff. Keep calm, everyone. And if you want to carry on and consider buying an EV or know somebody that is considering it themselves, I have 3 key questions for you. If you buy an EV, where will you charge it at home? Now, you can own an electric vehicle without charging at home, but you're not going to enjoy it as much. About a third of Americans live in a situation where charging at home would be difficult, in an apartment, or they park their car on the street. You'll need an outlet in your garage or driveway. Charging at home is cheap and convenient. I go much deeper into this subject in my next video. What is a common driving scenario for you? Something you do once or a couple of times a week? I think this is kind of a trick question because even people with crazy long commutes, active lifestyles, demanding children, they typically don't drive more than 100 miles a day on a daily basis. So an EV with 250 miles of range won't break a sweat. Then what does a less common driving scenario look like? People will tell you that they cannot own an electric vehicle because they take long road trips. You can road trip in an electric vehicle